Welcome to the Economist in Your Ear podcast. What happens when you take some of the brightest minds on the planet, give them limited resources, and ask them to build the future? Do they fall behind, or do they find a way to rewrite the rules of innovation entirely? Today we are looking at an article titled Drum Tower Newsletter: Who is Behind China's Latest AI Breakthrough? And the mission for our conversation today is to explore this incredible story of talent, sheer engineering ingenuity, and the rapid progress happening right now in China's AI labs. We are going to look at how these innovators are turning massive constraints into massive strengths and reshaping the global tech landscape.
Yeah, it really is a fascinating shift because, there has been this lingering assumption in the tech world that to create frontier-level AI, you basically need unlimited access to the absolute top-tier hardware.
Right, just throw infinite computing power at it.
Exactly. But what is unfolding now is a masterclass in how imposing constraints on a brilliant team actually forces them to focus entirely on structural elegance. They are building incredibly sophisticated systems precisely because they cannot rely on brute force to paper over inefficient code.
So to really understand how the rules of innovation are being rewritten, we first need to look at the team that just leapfrogged everyone's expectations.
Definitely.
We are talking about Zhipu, or also known as Z.AI, and they just launched a new large language model, GLM 5.2, back on June 13th.
Yeah, and that launch is what shatters the old assumptions. Because historically, Chinese models were viewed as, highly practical and affordable, but maybe just a step behind the American labs. GLM 5.2 changes that narrative entirely.
It is kind of like a brand everyone thought was just a reliable budget option, suddenly releasing a luxury supercar that beats the established titans on the track.
That is the perfect analogy, yeah. It is both more capable and more premium than local rivals, and even some foreign models. And a lot of that comes down to their pedigree. Zhipu spun out of Tsinghua University in 2019.
Which is often called China's MIT, right?
Right, though even that might undersell the raw talent there. It was started by two professors, Tang Ji and Li Huanzi, and they have assembled this incredible team of over 500 researchers.
And I think the article noted that roughly 2/3 of them are from Tsinghua and comparable top universities.
They are. And there's this great detail that perfectly captures the vibe. The author called them on a Tuesday from London, which meant it was 9 p.m. in Beijing, and the researchers were all still fully immersed at the office, just hard at work.
Oh, wow. Still going at 9 p.m. That is intense.
It is a collective obsession. But, you might wonder how they built this premium supercar model so quickly, because it is not like they have an easy road.
No, not at all. They face real hurdles, right? Like data bottlenecks and definitely curtailed access to the most advanced export-controlled computer chips.
Exactly. But the surprising answer is that they achieved this not in spite of those constraints, but almost because of them. Chinese engineers are using these limitations as a spur for ingenuity. They are squeezing the absolute maximum performance out of every single chip they have.
So they are diving into the software to make it hyper-efficient.
Yes. They are carefully optimizing their models to run on chips made by the national champion Huawei. Specifically, the Huawei Ascend chips.
Which means they basically have to rebuild the training infrastructure to communicate perfectly with that domestic hardware.
Exactly. It is partial for now, but it is growing. And by stripping away legacy code to do this, they end up with this incredibly lean training pipeline, which leads to this fascinating concept researchers call spikiness.
Spikiness. Okay, tell me more about that. Like, what does a spiky AI look like?
Well, researcher Zheng Qingkai notes that while the model's overall generalized performance across every random topic might still be a work in progress, GLM 5.2 is incredibly whizzy in very specific areas.
So it spikes on the capability graph. Like what areas?
Like extended coding. They are among the best in the world at complex coding tasks, which requires deep logical reasoning.
Wait, really? But if they are squeezing this much capability out of limited hardware, what happens when they actually start scaling up their computing power?
Right, that is the big question. And the answer to how they scale lies in a really distinct approach to global collaboration. It is an ecosystem built on sharing openly rather than locking everything in a corporate vault.
Okay, so you were talking about open weight models. For anyone listening, releasing the weights means publishing the actual mathematical parameters so anyone with a powerful enough setup can run or inspect the AI locally.
Exactly. And just to give you a sense of scale, GLM 5.2 has 744 billion parameters.
Which sounds massive.
It is. But Anthropic's most advanced model, Mythos, is rumored to have 10 trillion.
Wow, 10 trillion versus 700 billion. That is a huge gap.
On paper, yeah. But Zippu's boss, Mr. Tang, expects a Chinese lab to actually match Mythos this year.
We match it this year.
Yes, because there is this healthy back and forth happening. Chinese labs are advancing rapidly by learning fast, building efficiently on shared global advances, and then doing their own bold experimentation.
I mean, I have to jump in here and be a little skeptical. Isn't it risky to just hand over the brain of your AI to the public? You just optimize this incredible model, and now you are just giving it away.
You would think so, but Zheng Qingkai views this through a philosophy he calls collective defense.
Collective defense. How does that work in practice?
Think about it. If you keep it closed, you only have a few dozen people testing it. By opening the ecosystem, you have thousands of global engineers inspecting the weights, spotting errors, and defending against things going awry.
Oh, I see. It is like crowdsourcing global security.
Exactly. Transparency makes it fundamentally safer and allows it to iterate much faster. But while giving away the model weights sounds incredibly generous, there is actually a very sharp, highly profitable business engine driving this.
Right, because open sourcing the weights is one thing, but actually running it is another. As engineer Wei Ping points out, a 744 billion parameter model is way too massive to run on a standard home computer.
Yeah, you can't just boot it up on your laptop. So Zippu hosts the model in their data centers and serves it to enterprise customers for a fee.
Okay. So they manage the hardware, and the companies just pay for access. And the financials there are really impressive. The article mentioned they are doing this at a 20% gross margin.
Which is fantastic for inference costs. And the business logic is that as the models get smarter and more capable, they can command even higher prices.
Which brings in the revenue needed to train the next generation.
Exactly. And looking to the future, Anthropic recently noted that AI is actually finding ways to improve itself. And Zippu is fully focused on this self-improving system.
That feels like a huge paradigm shift.
Yeah.
How does that change what the engineers actually do?
It completely changes their hiring strategy. The top quality Zippu looks for in new researchers now isn't just raw coding ability. It is how well they use AI to accelerate their own problem solving.
Wow, so they want people who are good at orchestrating the AI to do the heavy lifting.
Yes. As Zhang says, the goal is to free the potential of all our compute.
It's like moving from selling someone a high-end calculator to renting them time on a supercomputer and hiring people who are experts at getting the supercomputer to upgrade itself.
That is a brilliant way to put it. It is a completely symbiotic workflow that iterates faster than humans or AI could alone.
It really is an amazing story of resilience and creativity, which leaves us with a truly fascinating thought to explore. If AI labs are now hiring engineers specifically based on their ability to let AI accelerate their problem solving, and the AI is simultaneously learning to improve itself, are we approaching a moment where the greatest technological leaps won't come from human aha moments, but from humans simply learning how to ask the AI the right questions? Thanks for listening. Follow us for daily insights into world affairs. And don't forget to like, comment, and share.